So welcome to the second semester, and this is our first homework assignment. Watching this video, and we'll be going over a lot of the questions tomorrow in class that deal with this video. So just the expectations is one thing we're going to cover in this video. Notes for assignment number 1, so you want to make sure you have your notebook out and your pencil ready to take some notes. We're going to be talking about two specific things: zero exponents and negative exponents. Let's go ahead and get started with some of our expectations. Remember that when you come to class, you need to be in class when the bell rings, and when the bell rings, you need to be headed towards your seat. And then you want to make sure that all your materials, your computer is charged and ready to go. You have a pencil, you have a calculator, and that your homework is finished. You have your notebook, and you're all set to go for class. Third thing is, if you are absent, then it is your responsibility to make up your work. Everything will be in Canvas, and so you can watch the video, you can do the homework assignment, everything that you would need to be doing in class, you can do online as well. So that's something that you need to make sure that you are cognizant of when you are absent. Make sure you're neat and organized. If you're neat and organized, it helps prevent a lot of the silly mistakes that you make in math, and it'll make you more successful. So let's go ahead and get started with these 4 problems. I want you to pause the video and try these 4 problems on your own, and just guess if you're not sure what the correct answer is. And then we will come back when you finish. You can pause the video, and then when you finish, restart the video to make sure that you have them correct. All right, so let's go back here. And 3 to the second power, that means 3 times 3. 3 times 3 is just 9. So the first one is 9. 2 to the 5th means we have 2 5 times. So we have 5 factors. They're all 2. So 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. 4 to the 0, this is going to be surprising to a lot of us, but 4 to the 0 power is 1. We're going to talk about why it's 1 here shortly. 5 to the negative second, this is another tough one, but 5 to the negative second is 1 over 25. Now, if you used your calculator, that would be 0.04, but I would like for us to write it as a fraction. And again, I'm guessing that a lot of us may have gotten 1 and 2 right, but the ones that caused a lot of difficulty were 3 and 4. And 3 is a 0 exponent. 4 is a negative exponent, the little number to the right of the base number. So here the base is 4, the exponent is 0. Here the base is 5, and the exponent is negative 2. So we're going to talk about what happens specifically when you have a 0 exponent and a negative exponent. We're going to do this by following certain patterns. We're going to start with 2. Let's say we start with 2 to the first power. We have 2 to the second power, 2 to the third power, and 2 to the fourth power. And we want to figure out what all of these are equal to. Well, 2 to the first power we know is 2. 2 to the second power means 2 times 2, which is 4. 2 to the third power is 2 times 2 times 2, which is 8. 2 to the fourth, 2 times 2 times 2 times 2, and that is 16. You can see there's a pattern developing here on the right-hand side. So what I want to do is this. I'm going to take 2 to the 0. And here we can look at this pattern. Here we have 16, but half of 16 is 8. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. And so 2 to the 0 power is 1 because it completes the pattern. We can do the same pattern with another one. Let's say, for example, we have 10 to the 4th, 10 to the 3rd, 10 to the 2nd, and 10 to the 1st. And we try to figure out what all of these are equal to. Well, 10 to the 1st, that's just 10. If I have 10 squared, that's 10 times 10, which is 100. 10 to the 3rd is 3 tens. 10 times 10 times another 10, which is 1,000. 10 to the 4th is 10,000. And so you can see if we follow the pattern here. Here it's kind of like I'm knocking off zeros, or I move the decimal back 1 space. So to go from this one to this one. So this is 10,000, it becomes 1,000. 1,000 becomes 100. 100 becomes 10. 10, if I move the decimal over, becomes 1. And so you can see with both the rectangles in there that Anything to the 0 power gives me a 1 because it completes the pattern. Doesn't matter what it is. It could be 5 to the 0 power. 5 to the 0 power is going to be 1. And we can show that by patterns. And so what happens with negative exponents? Let's say we continue this first pattern down here, 2 to the negative first, 2 to the negative second, 2 to the negative third, and so on. Well, you can try this on your calculators, but you can also look at the patterns here. We had half of 16 is 8, half of 8 is 4, half of 4 is 2, half of 2 is 1, half of 1 is a half. Half of a half is a fourth. Half of a fourth is an eighth. So I want you to take a look at this. 2 to the third is 8. 2 to the negative third is 1 over 8. 2 to the second is 4. 2 to the negative second is 1 over 4. 2 to the first is 2. 2 to the negative first is 1 over 2. We can do the same thing with the tens here. If I have 10 to the negative first and 10 to the negative second and 10 to the negative third, and I just follow the patterns, it's like I'm dividing by 10. A tenth of 10,000 is 1,000. A tenth of 1,000 is 100. A tenth of 100 is 10. A tenth of 10 is 1. If I divide that into a tenth, I have a tenth. A tenth of a tenth is a hundredth. A tenth of a hundredth is a thousandth. So take a look at this. 10 to the third here is 1,000, but 10 to the negative third is 1 over 1,000. 10 squared is 100, but 10 to the negative second is 1 over 100. And so we have something that looks like this, 5 to the negative second. Well, that's the same thing as 1 over whatever 5 to the positive second is. Well, 5 to the positive second is 25. And so if we follow these patterns, here are the two big ideas for this video and for our homework assignment. Anything to the 0 power is 1. An example, a to the 0, that's always going to be 1. That's a big idea. Another big idea is this. Negative exponents can become positive. For example, if you have a to the negative nth power, that's the same thing as 1 over a to the nth power. So if it's a negative exponent, just put it on the bottom and it becomes a positive exponent. Two examples. Let's say we have 7 to the negative second power. Well, that's 1 over 7 to the positive second power. That's 1 over 49. The other thing that is true is this. If I have 1 over, let's say 3 to the negative second power, well, if it's negative and it's on top, I can move it to the bottom and it becomes a positive exponent. If it's negative and it's already on the bottom, then I can move it to the top and it becomes a positive exponent. That's 3 squared. This is equal to 9. 1 over 3 to the negative second is positive 9. 7 to the negative second is 1 over 49. I just move it from the top to the bottom and it becomes a positive exponent. So let's try these 4 examples. Number 1, 5 to the 0 power. Try it on your own first. 5 to the 0 power is 1. You can pause your video and do all of these if you want, and then turn your video, start your video again and see if you're correct. 4 to the negative third, well, that's a negative exponent. We want that negative exponent to be positive, so what we're going to do is this. We're going to write it as 1 over 4 to the positive third. Well, 4 to the third, that's 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. So that's 1 over 64. Negative 3 to the negative second. Well, again, I want this negative exponent to be positive, so I'm going to write it as 1 over negative 3. That doesn't become positive. That's just the number negative 3 to the positive second. And so this is the same thing as 1 over negative 3 to the positive second means we're going to take negative 3 times negative 3. Negative 3 times negative 3, that's a negative times a negative, which is a positive 9. And so negative 3 to the negative second is positive 1/9. Now, let's take a look at number 4. Here we have negative 3 to the negative second, but that's going to be 1 over negative 3 to the positive second. That now it's not in parentheses. And so this is the same thing as negative 3 to the second is the same thing as negative and then 3 times 3. The negative is not included with the exponent. So what I would do is I would take 3 times 3, which is 9, but then the negative still applies. So negative 3 without the parenthesis to the negative second is negative 9, which means I'm going to still have the 1 on the top, but I'm going to have a negative 9 on the bottom. So number 4 is 1 over negative 9. So let's see if we can apply that to something that looks like this. This looks challenging. But let's go ahead and simplify each of the different parts. First of all, 6 to the second. Well, 6 to the second power means 6 times 6, which is 36. So we can do that pretty easily. Then I have this a to the negative third. Well, I want to make that, I want to make that a to the positive third. So I have to move it to the bottom. It's going to be a to the third on the bottom. What is anything to the 0 power? Well, that's just 1. So I could put times 1 here, but 36 times 1 is just going to be 36. So it's kind of like that b to the 0 just disappears. On the bottom here we have a c to the second, so that's going to stay on the bottom as c to the second. But if I have d to the negative fourth on the bottom, I want it to become d to the positive fourth, but that means I have to move it to the top. It's going to be d to the positive fourth. So my final answer is going to look like this. 36 times 1 is just 36 times d to the fourth over a to the third times c to the second. And so my final answer would look something like that. This may not look a lot simpler, but I don't have any 0 exponents and I don't have any negative exponents. And so that makes this look be a lot simpler than what it was when we started. These are the kind of things that we're going to be doing on our homework tomorrow, or when we get to class tomorrow. So do the best on your homework assignment, and we will see you in class tomorrow.